Alright, we'll be integrating x squared, but we are not going to be using the power rule of any kind. Meaning that we are not going to bring the power to the front and then minus 1, no power rule for derivative. And also, of course, do not add 1 to the power and then divide it by the new power. No power rule for integral as well. And to make this even more special, I will show you guys before black pen, red pen, I was like this. And this right here is actually for Parker and Ray. We did a podcast together a while ago, so go ahead and check that out. Link will be in the description. So this right here, it's for you too. Alright, so I don't know if I can still do this one now. I haven't practiced this for a while. I will be looking like an octopus, so it will be kind of funny, right? So here we go. So to integrate x squared without the power rule, well, what we can do is we can let x equal to sine theta. Okay, this is so bad now, I know. But I will continue. Well, let's go ahead and do our usual business. Dx is equal to the derivative of sine, which is cosine theta d theta. Alright? And I'm not going to cut this video. This is the only take, so you will see if it works or not. And then maybe this will be really hard to watch. Mainly for entertainment, right? Alright, so now this right here will be equal to the integral, and the x is equal to sine theta, and then we have that square. So of course we can write that down as sine theta square, and then the dx is equal to that, which is cosine theta d theta. And believe you or not, I was much better before I hold 2 markers in one hand, and it's all about practice. And then yeah. Alright, now how can we take off this though? Well, if you take a look, this right here, do not do u sub. If you do u sub, then you defeat the whole purpose, right? So let's see. Well, this right here is the same as sine theta times sine theta, right? So I'm going to write this as integral, and then I'm going to put down the first sine theta in black. And then have a look right here. Of course, we can write this down in red, sine theta, and this right here is cosine theta, and then d theta. And the good thing about this is that d theta can be in black right now. The good thing right here is that this right here, we actually have a nice identity for it. It's the sine of 2 theta, but divided by 2, right? So in fact, I'm just going to replace this with the following. So the first sine theta stays the same, but this right here, it's the same as saying sine of 2 theta, but then we will have to divide it by 2. And then of course we have the d theta. Now we can of course bring the 1/2 to the front, and let's go ahead and do that. So we have the 1/2, and yeah, this is how I used to entertain myself when I was starting teaching back in like 2011. Now, here we have sine theta times sine of 2 theta. What can we do with it? Well, we will have to use a formula for it, and the formula is actually, let's take a look. We need the sine alpha plus sine beta. Let's see. This is the shirt for teachers, so you have to be a teacher in order to wear this. And it's really convenient. And alright, I found it. So let me just put that down right here on the side for you guys. Right here, the formula says if you have sine of 2 angles, and you know I'm going to change the angles in red, so I'm just going to write down alpha plus beta. Here's the fish, and here is the beta. This right here is equal to sine alpha, I'm looking at the wrong one. I'm looking at sine alpha times sine beta, right, this one. This right here will be equal to, let's see, it's right here. 1/2 and cosine, and then the first one you subtract, and then the second one you add. Okay, so this right here is 1/2, and then the first one you subtract. So you will do alpha minus beta here. So alpha minus beta, alpha minus beta, and then minus cosine of alpha plus beta, right? Cool. Alright, so right here, I'm looking at sine theta times sine of 2 theta. Alpha is the theta, and beta is the 2 theta. So we have to have another 1/2. And here I will actually continue with my blue. Here we have the 1/2 here. And then we will end up with cosine alpha minus beta, theta minus 2 theta. We will get negative theta. Right? So again, this is because alpha is the theta and then minus the beta, which is the 2 theta. So this is what we have. Oops. 2 theta, that's not a B. So that's that. All right, and then we can take cosine and then alpha plus beta, so theta plus 2 theta. That will give us a nice 3 theta. So that's actually really good, strong color. Like this. Another parentheses. Good. And actually, let me do that. So this is theta and then plus 2 theta. All right, so like that. And then, of course, don't forget to put down the d theta to close everything, right? Now, let's see. This right here becomes, we have the 1/2 times the 1/2, that's 1/4. So this together, I don't have purple, otherwise I'll use purple, but 1/4. The good thing is that cosine negative theta is the same as cosine of theta. So this right here, you can just look at this as cosine of theta. And when you integrate cosine theta, you end up with a positive sine theta. So the result is first we have positive sine theta. Next, integrating cosine 3 theta. Integral of cosine is positive sine. So the negative will stay, and then the input stays. So we have the 3 theta inside. But remember, you have to go and divide it by the derivative of that. So you divide it by 1/3. So let's go ahead and put down 1/3 right here. You can do a quick use up for that if you would like. So we're done with the integration step. But now we have to go back to the x world. And the problem with this is that sine 3 theta is equal to what? Don't worry, yes, it's on my shirt, alright? So, right here, let me just put this down for you guys. Sine of 3 theta is equal to 3 sine theta minus 4 sine 3rd power theta. So this right here is equal to 3 sine theta minus 4 sine of 3 theta. And in fact, you know, when I was first start teaching, there are plenty of times that we'll have to look at notes. So yeah, that's why, yeah, it just kind of reminds me the good old days. All right, now let's see. Guess what? X is exactly our sine theta. So here, this right here we have 1/4. Sorry. Here, this right here is 1/4 times that, which is 1/4, and sine theta is x. Yeah. Next, this times that. Well, 1/4 times 1/3 is minus 1/12. And then let's go ahead and put this down. Here we have 3. Perhaps I will continue with blue. Here we have 3. And then the sine theta is x. And then minus, here we have 4. And then sine theta is x, and then to the 3rd power. So we have x to the 3rd power. See? We didn't use power rule at all. And now, yes, you'll see this right here is 1/4x. And then this right here is reduced. You also get 1/4x. And don't forget negative times negative. You get a positive like this. 1/12. And then, look, this is negative 1/12. One of the most famous fraction, right? Anyway, this times this becomes positive. And then you get 1/3 x to the 3rd power. And yes, you know, this and that cancel out. In the end, of course, the answer is just positive 1/3 x to the 3rd power. Yes, we are done. So finally, we can put down the plus c, and this right here is it. Right, really cool, right? And in fact, there's another substitution, and the truth is, you can substitute whatever you want, but sometimes your substitution might not help you. Another substitution that will make this work out nicely is you can let x equal to e to the t's power. In that case, you don't need to use the power rule either. but you still have to use the chain rule. See, I didn't use the power rule at all, which is very cool, right? So anyway, hopefully you guys all enjoyed this video. If you do, please give me this video a like. Thank you so much, and as always, that's it.